Hello, I'm Munjumun to introduce the paper about query-dependent detection transformer. In this paper, we highlight the temporal burden to watch the full video and the need to capture the desired moments and the video highlights. For example, given a football video that usually runs about 2 hours, many people often cannot afford their time to watch the full video or wants to see the replay of winning goal. In this context, the role of text query is very important since it reflects the user need. With this motivation, our query-dependent detection transformer ensures that texture information is fully exploited in capturing desired moments and highlights. It consists of cross-attention transformer, negative learning, and input adaptive salience token, which is marked with red, blue, and green boxes. With these modules, QDDTR ensures that the texture info is exploited in forming video representation. The goal of video moment retrieval and highlight detection is to handle the user's need to capture the desired moments and the highlights. This is because video sources are often very long to watch the full video. To be more specific with an example data, we have text query, temporal box, highlight scores per video. Text query represents the user's need. The temporal box indicates the moment corresponding to the text query, and the highlight scores reflects how the frame matches the text query. Then with the video and the text query, we say that moment retrieval is to predict the temporal box, and highlight detection is to predict the highlight score. For the background, there are two recent works with transformer architecture. They either use detection transformer to capture the moment as the set, or use transformer to predict scores for each frame and aggregate as a moment set. However, although exploring the texture information is essential in searching for query-relevant moments and highlights, the importance of text query is overlooked in their works. For example, Moment ETR has just concatenated the text features with video features and use surf attention layers. And UMT utilized surf attention layer within single modality features before text condition, which makes texture information not fully exploited in representing frame-wise video representation. So, to fully utilize the texture information in predicting video highlights and desired moments, we propose query-dependent detection transformer. It consists of three parts, which are marked with red, blue, and green boxes. First, cross-attention transformer encoder is to make query-dependent video representation. Like the previous works that utilize surf-attention at the very first layers, we placed cross-attention layers at the very first to exploit the per-frame similarity to the given text query. To be concise with the role of cross-attention, it enables the unidirectional conditioning between video and text features. Second part is negative relation learning, which is to learn the general relationship between the video and text features. We point out that the previous methods only focused on learning video query relevance within matched positive pairs, that it cannot learn the general relation between modalities. Instead, by making the model aware of negative video text pairs, the model is taught to be more precise in estimating the similarity between given video and text queries. Our last component is an input adaptive saliency predictor. Typical saliency predictor consists of multi-layer perceptron or single fully connected layer as shown on the left side. However, this architecture design neglects diverse nature of video text pairs, since MRP layer provides identical saliency criteria on every video text pair. On the other hand, the proposed saliency predictor utilizes input adaptive salience token that determines the saliency criteria based on input video text pair. Now, it's about experimental results. This table shows the results on QV highlights dataset. Left 5 columns are the results for moment retrieval, and the others are for detecting highlights. As can be seen in this table, the proposed query-dependent detection transformer surpasses previous methods by a large margin. Next is the analysis with ablation study. On the left side, every component is validated with the quantitative numbers, and the figure on the right side shows the saliency histogram on positive and negative pairs. Here, positive pairs are matched video text pairs provided in the dataset, and the negative pairs are the pairs with the video irrelevant text query. From the left top to right top and left bottom and right bottom, we observe that the score distribution changes as each component is added. What you can find here is that as the overlap between positive and negative saliency score distribution is being reduced, the model is taught to better recognize the video text relevance and distinguish the positive and negative texture queries. Lastly, we visualize the moment and saliency prediction results of query-dependent DTR. With three levels of queries, positive, semi-positive, and negative, we observe that the saliency score estimation is adequate. Also, we can see the moment prediction of query-dependent DTR is sometimes more accurate than the provided ground truth label. To sum up, our contributions are: first, we found that the previous methods only uses queries to play an insignificant role. That is, they may not be capable of detecting negative queries and video query relevance. Second, to tackle this issue, we proposed query-dependent detection transformer with three components. Cross-attention transformer encoder is to explicitly inject the context of text query into video representation. Negative relation learning is to encourage the model to estimate precise accordance between video query pairs. And input adaptive saliency predictor is to adaptively define the criterion of saliency scores for the given video query pairs. Third, with this competence, our approach is verified to be superior to existing state-of-the-art methods with extensive experiments, and also show that increasing the involvement of text query is essential. Thank you for listening.